What do we know about parallel lines? Whoops, limes. We don't need to eat limes. Lines have the same gradient. So where do they intersect? Never. Perpendicular inverse gradients. And what does that mean? So for example, if my gradient was 2, what's my inverse? -½ What if I had 2/3 as my gradient? -3/2, right? You're just flipping them. What was my lovely formula that I used to get the equation of a straight line last week? Good. All right, so this, all I need is the gradient and a point, and then I can find my equation. So usually that's what you'll be given, right? So let's do an example of that. All right. So let's just rewrite it here. Y minus y1 equals mx minus x1. All right. So let's say that the line y equals -1/4 x plus 2. I want a perpendicular line that passes through to -8. All right, let's put that information into our formula. So what do? Y plus 8, good, because it's y minus -8 equals 4 x minus 2, good, because the inverse of -1/4 is +4. So y equals 4x minus 8, and then bring this across as a -8. So y equals 4x minus 16. That is the equation of a line that is perpendicular to this and passes through this point. Remember that from last year? So what does that mean? Tell me what the product of perpendicular line gradients are. -1, right? So if you multiply the two gradients of perpendicular lines, you will always get -1, right? -1/4 times 4 is -1. And that will be true for any perpendicular lines, yeah? So anything multiplied by its inverse should give you -1 like that. We know how to find gradients. Basically, a lot of the times we're going to be doing this exact same thing, but with like annoying fractions. If you're asked to do the same thing with parallel lines, obviously you just keep the gradient the same, right? No problems. But they won't always give you the equation in this lovely form, right? They won't always use y equals mx plus c. They might write it in a different way, which means you need to rearrange it first so you can see what the gradient is. Then you can do your alterations. Does that make sense? And just like last lesson, you may need to find an unknown piece of information in the middle instead of finding, the gradient, or, they might tell you what the gradient is and ask for C as part of this, but it's all the same stuff. Yeah? All right. I don't think I need to say anything else today. We're going to do exercise 3.2. Off you go.